Hello. In this video we're going to work through this problem here, and that is we're going to solve the following linear system graphically. So the first thing I'm going to do with this problem is I'm going to actually number my equations. So we'll call this equation 1, and then we'll also color code them. We'll call this equation 2. Whenever we're working through these problems, a little color coding goes a long way. So really, one of the main ideas that we're checking you can do here, let's just go main ideas. We're checking if you can graph y equals mx plus b. Okay, so the first equation, which is equation 1 in blue, is already in y equals mx plus b. So we see that for the blue equation, m is equal to 1/2 and b is equal to 1. So therefore, what I can do then is I can just put a point at the y-intercept 1, and then I can count it off. So up 1 over 2, up 1 over 2, up 1 over 2. Can't see the points because of the glare. Up 1 over 2. And then I go back 2, down 1, back 2, down 1, back 2, down 1, back 2, down 1. And then I can get a ruler out and I can connect these. Really important that you use your entire page. Sometimes students will just do a little bit of the page, use the entire page, put arrows on the end. So the challenge with the green one, which is 3x plus 2y equals 1, is that it's not in y equals mx plus b form. So let's take a second and do that. Y is equal to negative 3x plus 1. So 2y is equal to negative 3x plus 1. So y is equal to negative 3 over 2 x plus 1/2. So one of the things about the green equation, or equation 2, is that we can't put 1/2 easily on this. So what I'm going to do in this case is I'm actually going to test a point. So let's test a point that makes sense. And that point, let's test a point that is x equals 1. So if I put x equals 1, I'm going to get y is equal to negative 3 over 2 times 1 plus 1 over 2. And so I get negative 3 over 2 plus 1 over 2, which is going to give me negative 2 over 2, which is negative 1. So therefore we know the point 1, negative 1 is on this line. So I go 1, negative 1, and there it is there. So now I simply count off the slope. And so I see that the slope is negative 3 over 2. So down 3, 1, 2, 3, and across 2, 1, 2. 1, 2, 3, 1, 2. And then I can go up 3 and back 2. 1, 2, 3, 1, 2. Now what we can see right away with this question is actually this isn't an ideal question for this situation, because 1, 2, 3, 1, 2. It actually doesn't work out nicely. There we go. So this question doesn't work out nicely, so I can't actually read the point of intersection or the solution to this system from it. So in this case, I would actually then fall back on using either substitution or elimination to solve that. So my point of intersection is right here, and I could approximate that, but I can't actually give an exact value because this doesn't work ideally.